This is Torrance doing with Lab 5 motion of falling objects. My first observation was to watch a wallet that dropped rapidly and then to drop a paper towel that dropped slowly. The main result that we're trying to prove here is that air resistance is going to cause them to fall differently based upon their mass ratio. Some other objectives we're trying to look for is to compare the falling velocity of the two different objects. With this, we can find the terminal velocity and the difference between our air friction to weight ratio. The first thing I did was record my two videos of a paper towel falling and a wallet falling, and then uploaded them in Tracker. The first video that we have here is the paper towel that's falling. Here I've set my axis, you can see, to when it falls. It just falls at this rate. So when I play it, you can see that my points that I found are right along that. The length of my video is about 0.25 seconds, and my length scale is about 0.05 meters. And then here was all of the data that I gathered from this. Same thing with the wallet. If we just watch it fall, I set the origin to right here at the center of my object, so it would just fall. So there we go, and we can watch that. The time of this video was 0.417 seconds, and I set my length scale to 0.2 meters. The average location is just plotted along these lines with the gather that I dated right here. So once I've analyzed these in Tracker, I went to my VPython program, and this was my computational model that I used. The first thing I had to do was set the mass of my object. So for this instance, I used the mass of my wallet, which was about 0.50 grams, and then my ball position, I'm just using that vector as 0, 0, 0, and same thing with the velocity, since these are just starting at an initial time. My time was 0.417 seconds, which is what I had gathered in my Tracker data. Pretty much, this model is going to show like the gravitational force, which is equal to 9.81, and my f-grav vector is just 0. The negative ball that's falling over here in this program. So that shows that the ball. There's my ball velocity and my ball position. So once I run this program, you can see that it starts at an initial position and just falls. This graph just shows it falling rapidly. So once I gathered the data from that, I used an Excel sheet to compare the differences between my observations to my computational model. This one right here shows the paper towel. The blue line is from the model that I used, and I changed my mass in that model to represent the mass of the paper towel. Here you can see that this line just towards the end falls off to be a linear line, which it eventually reaches its terminal velocity. But as you can see, the line that I got from my Tracker, I didn't have as many data points due to the short length of the video of the paper towel falling slowly. But if this was to continue, I think that maybe it would slope a little bit more. So then I did the same exact thing with the wallet. The blue line represents the model data that I'd gathered in VPython, and here was mine. You can kind of see the difference. Same thing with the blue line, it falls off towards the end, and it eventually will reach its terminal velocity. If I gathered more data points of mine, I think mine would do the exact same.